Thank you and good morning, everybody. So it's a pleasure to be here. And first of all, I would like to start by a special thank to ILSI Latin American branches for inviting me to this great meeting. It's an honor for me to be here and to talk about technology that really passionates me a lot. And it's HPP technology, high pressure technology. And the application of the technology, I believe Dr. Cristianini has talked a lot about that, and it's very clear. Thank you, Dr. Cristianini, for this nice introduction to my talk. But what are the challenges beyond food preservation? Because normally this technology has been used as a food preservation technology. So I will talk about what the challenges beyond food preservation are. I don't have anything to disclosure. It has been a kind of my experience and during my doctoral studies and some of my work that I have done as well. So I just want to share with you all this experience as well. So let's start by what is high pressure processing. I don't want to go so deep and to get you bored about this because Dr. Cristianini has said everything about. So just a short introduction. As he said, high pressure processing technology is a cold pasteurization technique. Some people believe that it's not that cold pasteurization, that it's a little bit thermal pasteurization because there is a kind of heating during the processing as well, but it's a short heating during the processing. But anyway, it's not that high increase in temperature that we can call it as a thermal processing. So it's a cold processing pasteurization, very promising technique that is already approved by the FDA and which is based upon the application of very high level of hydrostatic pressure in the range of 300–600 megapascals on already packaged food with the aim to reduce or eliminate harmful bacteria and extend the shelf life of the product. So HPP usually extends the shelf life of raw foods from few up to 45–90 days, making the food really stable and easy to transport, hold, store, and sell. So it's a promising, but it's not the panacea anyway. So we have to be careful about so many things as well, as somebody said here. It brings so many advantages from the industry point of view as well, which are food safety, because it destroys pathogenic microorganisms, as Dr. Cristianini said before. Everything has been said about that, such as Listeria, Salmonella, Vibrio, some norovirus that produce diarrhea. There are some scientific work about that. And E. coli as well, for instance, it reduces E. coli. Of course, it brings some food quality and customer satisfaction because, as Dr. Cristianini said, it keeps all the flavor and nutritional value of the food product as well. It doesn't affect color in an important way. And it's amazing. This technology is just to keep an idea, is like introducing yourself into the deepest part of the ocean, that is the Marianas Trench. So it's 11 kilometers below the sea level. But there is an adiabatic heating, but it doesn't affect small macromolecules, and it doesn't affect neither the sensorial, neither the nutritional properties. They remain almost intact, lowering, of course, any complaint and returns from the customers. So the customer is really satisfied with the product. It's amazing. I have tested some orange juice, 6 months processed, and I tried the orange juice, and it tastes like just fresh squeezed. It's amazing. It improves quality along shelf life because it drastically reduces the overall microbial spoilage flora without affecting the sensorial properties of the product. And we can use it as well as a clean label because we can avoid the use of any food preservative, and we can call it that it's a natural or is additive-free product. Obviously, it's considered an environmental friendly because its operation requires only electricity and water, which, by the way, the water is totally reusable. We can use it again and we can recyclable. So Dr. Cristianini said it's an on and off equipment, so it's really easy to manipulate. It brings a really important advantage from the innovation and competitiveness point of view, because products that couldn't be thermally treated before, now we can be processed by high pressure technology, giving innovative propositions for the food industry. However, there is even more beyond this, and it's related to the food product innovation and competitive advantages. That I mean is, before it was only from the technological point of view, from the application of the technology for food safety reasons, but now we can have a large amount of product innovation that brings a differential factor. They are related to the changes on the cell structures and food macromolecules like biopolymers that induces, as Dr. Cristianini said, changes on the structure of the system and thus affects important properties such as texture, water binding, and gelatination process. Actually, the last paper that we worked with was accepted for publication last year in 2018, and it's about the addition of whey proteins on gels, and it increased the elasticity modulus by applying high pressure technology. So it brings us a novel food applications, not just for the food preservation, but for the development of innovative textures and products with a better sensory performance, because the sensory performance of a product is related to the structure and is related to the way the whole system is composed by. So let's talk about a little bit the effect of high pressure processing on milk proteins. Dr. Cristianini said before as well that HPP affects size, shape, and conformation of various milk proteins. When they change, all the molecular structures change and all the interactions change as well. So the relation between water and solids and all the food components will change as well, and the structure of the product will change, bringing some changes on the protein functionality of the product. So we all know that native proteins are stabilized by covalent bonds plus electrostatic interactions, hydrogen bridges, and hydrophobic interactions. However, at relative low temperatures that we work with, between 0 and 40 Celsius degrees, covalent bonds are almost not affected by the HPP technology. So the primary structure will keep almost intact by the technology, yeah? But, however, this technology will affect the secondary, the tertiary structure, and the quaternary structure anyway, so we have to be careful on these changes. When this secondary, tertiary, and tertiary structure change, they will generate, for instance, an irreversible denaturation of milk proteins, and they will create anyway an interaction, for instance, in a milk system. They will create an interaction between whey proteins and caseins, giving a kind of small aggregates that they will make a kind of replacement of fat in the mouth, so giving a nice mouthfeel. As I said before, it will affect molecular interactions interactions among components, and will change the phase equilibrium phenomena among water, air, and solid components of the food systems. And as I mentioned before, the casein whey protein interactions occurs, leading the formation of small, really small aggregates into the system that they will generate a different sensory perception in the mouth. As a result, there is a change on the micro and microstructure of the system that in turn will lead to a change in, for instance, foaming properties of the whey proteins, viscosity of the system, and the structural effects that may affect the perception in the mouth. Those beneficial effects that maybe we have not considered, we know that they happen, but we have not considered it from the industrial point of view, are rheological changes for better sensory perception, because the sensory perception is really close link to the structure of the system as well. So it will help us to lowering costs by increasing water holding capacity, increasing as well the amount of air we can introduce into a system as well, lowering the weight and increasing the volume as well. It will improve sensory quality of food, of low-fat foods like milks, ice cream, sauces, and creams. My personal experiences, we have introduced low skimmed milk, 0.1% of fat. We introduce it into the HPP device, and after the treatment, very short treatment, we test it, and it tastes like the whole milk product. It was amazing. We have expert people evaluating, and they couldn't find any statistical differences between the skim milk and the whole milk. We couldn't find it, not even in the color, because there was not a change in the color, there was not a change in the viscosity, and there was not a change on the mouthfeel neither. So that's important characteristic of this. Improved yield and rheological properties, especially during cheese making processes. So we can introduce whey proteins into the milk system if we can process with the high pressure processing technology, and then we go to produce cheese, and it will change. First of all, the yield, but as well the elasticity modulus will increase, giving a better texture of the cheese. And will increase the yield, which means cost, and will means competitiveness as well. It's a difference with the competence. And it will help us to get novel textures without using foaming or thickeners agents. So as I told you before, we can just have clear labels. So now, what is beyond food preservation? As we are seeing, HPP processing opens an impressive opportunity to design better textures to meet the needs of food consumers. It's not only for longer shelf life or freshness, it's for better textures and to get more impressed about the product we are selling out. So, as I mentioned it before, we can get some skim milk that tastes like whole milk. Or we can produce low-fat ice cream with a great oven room. That's why you have this. Could you imagine a nice ice cream, but full of air, but tasting like creamy and full-fat product, tasty and with impressive mouthfeel that you can notice. So for people who really know to decrease the amount of fat, but they are really refused to do it because they need to get to feel a nice sensation and another experience to have the food. So this is a really nice alternative and really nice choice. So we can get as well, could you imagine, low-fat sauces and creams with a protein content. So it will become a little bit healthier because we can declare protein. If we add whey protein, we process the sauce or we put it into a high processing machine. So we can increase the amount of protein with full fat taste product with a lower fat content and very delicious and creamy mouthfeel. So it's a good advantage for the consumer as well. Anyway, something that I really want to point out is how to avoid any fraud. As I told you before, we can introduce some air, we can introduce more water, but it could lead to some kind of fraud from people. But there is a challenge here, is how to avoid any fraud without constraining the development of this technology that is really promising from the changes of the textural properties of the food product and to fulfill the needs of our consumers, as Dr. Cristianini said before. So, some conclusions some remarks. The application of the high pressure processing technology brings new challenges that are beyond food preservation, which are related towards an amazing opportunity for the design of novel and healthier foods, because we can add whey proteins, for instance, we can add some different proteins, we can diminish some non-desirable ingredients in the system, creating food innovative textures and creating new mouthfeels to impress and fulfill consumer needs. As we can see, the road is really broad, and it's time to start facing a new application of this technology that might bring important benefits for both the industry and the global consumer of foods. Special care must be taken with the regulatory issues in order to avoid possible frauds, but without limiting the development of the technology. We have to be careful about that, as I told you before. We can increase the amount of water, we can increase the amount of water as well that we can introduce into a system, but we have to declare that the product is a HPP processed, and try to do that, be careful with this, but trying to leave this technology to grow up, because it gives a lot of profits for the food industry as well, and it gives so many advantages from the customer point of view as well. So thank you very much for your attention. Gracias. If you have any questions.
Again, yes, questions? Please introduce yourself.
My name is Iyasu Abagas. I'm with Ajinomoto North America company. So thank you for your presentation, excellent presentation. I have just one question really. You talk a lot about high pressure pasteurization and so many of the benefit, texture, color, microbial log reduction, textural properties, etc. So as far as cost, can you talk about cost in terms of the comparable thermal technologies and also the adoption in the industry?
Excellent question, actually. That's the big challenge from the producers of the machines, because it's still a really, really expensive technology. But all the benefits that the technology can bring us, it paid back anyway. So it's an expensive technology, but can you imagine in a country where you don't have the opportunity, you don't have the chance to get the freshness taste of a product, like a fruit, for instance, a nice color. You get used to perceive the product as a treat product, this my jar flavor and the my jar color and everything. But if you get a product which tastes as fresh as just taken from the farmer, you will pay it. And consumers are really geared to pay for it. And obviously, it will pay back. Actually, HPP technology is an increasing technology that is giving a lot of profitable results from the industrial point of view. It's about $50 billion annually, and it's increasing. Coca-Cola has already some products as well. So could you imagine introducing whey protein into orange juice, for instance, increasing the texture of this, increasing the mouthfeel. So, but tasting like a really fresh, squeezed orange juice, you will pay for it. Obviously, for some special consumers. But by the time, every single technology, when they started, they are high price. But the price will be decrease anyway. Decrease. Thank you.
Johanna Dwyer from Tufts University. I wondered if you could tell us a little bit more. What are the immune properties of those proteins? Do they have
What are, sorry?
immunological properties of the protein? You said that some of the structure was changed, but some was preserved, and I wondered if they had affected immunogenicity.
Rheological properties? No, I couldn't get it. Yeah, rheological?
Sorry?
Did you say rheological properties?
Immunological properties.
Immunological, no. I mean, it's, it has been proved that, it has shown that it brings some good effects on the microbial and some viruses content of raw foods. So it will help anyway to have a safer products anyway. Yeah. Without affecting the nutritional content and without affecting the sensorial properties of the food system either. Some other question?
Thank you very much.
Okay, thank you.